All right, so here we are with Unit 4, Lesson 2, the slope formula. In the warm-up problem here, we're talking about a guy named Aiden chose points shown to counter the rise and the run to come up with a slope of 2 over 6 and simplified out to 1 over 3. Using the values in the ordered pair, how else could Aiden have found the rise to be 2? So if we're looking at just the rise, that means we're looking at just the y values. So how else could you get the number 2 if you're given the number 7 and the number 5? The answer they want you to come up with is that we can subtract them, 7 minus 5. Okay, then the follow-up question there is, how could he have used the ordered pairs to come up with a run of 6? Same idea. If it's the run, now we're talking about horizontal movement, so we're using the x values, 9 and 3. So how can you get the number 6 using the numbers 9 and 3? Again, that would be subtraction. Okay, so we have an algebraic way, all right, or an arithmetic way to get these values as well. So if we don't have a graph, okay, or maybe the numbers are too big to plot, we can still find the slope. This is our slope formula. y2 minus y1 over x2 minus x1. Don't be confused by the 2's and the 1's. The only significance that they have is to describe the point or the coordinate that that number comes from. Does it come from the first point or the second point? So if I use the formula to find the slope of the line that's graphed here, I first want to find 2 points. Just like we did last lesson, I want to choose a point, okay, that's at the intersecting part of a grid line. In this case, that point is 3, 5. Okay, choose another point. Again, that's at the intersection of those grid lines. And this point looks to be like 6, 3. So those are my 2 points, 3, 5. And 6, 3. Doesn't matter which one I call the first point or the second point, it's irrelevant. Okay? All right, so then I want to use my formula, y2 minus y1 over x2 minus x1. So that means I'm going to pull the y value from the second point first, which is 3. And then I'm going to pull the y value from the first point, which is 5. I'm subtracting them. On the bottom of the fraction, I'm going to pull the x value from the first point, which is 6, and the x value from the second point, which is 3. Of course, during this process, I have to remember that my x number comes first, my y number comes second. All right, that would be important in prior knowledge. Then I actually want to perform the operation. 3 minus 5 is negative 2. 6 minus 3 is 3. I observe that fraction to determine if it can be reduced or not. In this case, it cannot, so my slope ends up being negative 2/3. Now, if I have a graph where I can check that answer, in this case I do, right? I can come over here and draw my slope triangle and see that it's down 2 and it's right 3. Okay, which also gives me the negative 2/3 that I found algebraically. All right, let's take a look at a couple other examples here. All right, and I'll try to go through the process exactly the way that I would like to see you do it. All right, and it's always going to start with writing the formula down. All right, so y2 minus y1 over x2 minus x1. I prefer that you tell me which point is the first point and which point is the second point. That way, when we go back and check to see our work is correct or not, we can see, did we take the y value from the second point first, which is 7, and subtract the y value from the first point, which is 4? Right, these are your y values. And then in the fraction, did I put the x values in the bottom? So the x value from the first point, or the second point is 1. The x value from the first point is 2, so 1 minus 2. And if I plug all those in appropriately, all I really need to be able to do is subtract. 7 minus 4 is 3. 1 minus 2 is negative 1. So my slope ends up being negative 3. Now, I could leave it as negative 3 over 1. Nothing wrong with that. But if it could be simplified, I want to. Let's try the next problem. Again, same idea. y2 minus y1 over x2 minus x1. Tell me which point's which. This is my first point. This is my second point. Plug them in appropriately, right? These are the y values. That's what I'm taking first. So I'm going to have negative 5 minus 3. And then I'm going to have 5 minus negative 1. Now, that's an important part there. Keep in mind 2 things. First of all, the number itself is negative. That negative has to be in the problem. The formula has a minus sign. That minus sign has to be in the problem. Okay, you have to have both. All right, so when I actually perform this operation, -5 minus 3 gives me -8. 5 minus a -1 ends up being adding a positive, which gives me 6. I want to observe, can my slope be reduced? In this case, they're both even numbers, so it certainly can. This reduces to -4/3. So my answer is -4/3. I want you to take a minute and pause and go ahead and see if you can find the slopes of these next two problems. All right, and we're back. Okay, so if you did the first one correctly, you would have got 22 minus 11 on top, 10 minus 8 on the bottom. That gives me 11/2. I can leave it as a fraction if I want. I can write it as a decimal. And the bottom one here, my formula, plug in my y values on top, my x values in the bottom. This one comes out to be a special situation. I got a 0 on the bottom. So -3/0 should be a flashing red light for me, but if it's not, and I type into my calculator, it's going to give me an error message because the slope here would be undefined. This would be a vertical line. All right, let's turn the page. Okay, what happens when we start throwing decimals in the mix or we're trying to pull our numbers from a table? Nothing happens. Nothing changes. Still all the same steps. My formula is still going to be y2 minus y1 over x2 minus x1. I get to pick which 2 points I want. If you want to avoid decimals, then avoid decimals. I can choose this point and this point, and now I don't have to worry about decimals. Okay, so I'm going to have 6 minus 5 for my y values, right? Here's a y, here's a y. And then I'm going to have 2 minus 0 for my x values. All right, so that's my formula, right? Okay, so 6 minus 5 is 1. 2 minus 0 is 2. It looks like my slope ends up being 1/2. All right, try that next problem. All right, I circled the 2 that I use, so if you want your answer and your work to match mine exactly, use the same 2 points. Go ahead and push pause. All right, and we're back. Same formula. Y values on top, 15 minus 15, 8 minus 3. That 0 on top should be a flashing red light that this is a special scenario. When I simplify this, 0 divided by 5 is 0, and that ends up being a horizontal line. What about when we get a word problem? The process doesn't change. Okay, we still have a table. We still have x values and y values, right? This is my x column. This is my y column. Okay, go ahead and push pause. See if you can come up with a slope for that one. All right, we're back. Hopefully you use the formula, y2 minus y1. Hopefully you chose any 2 values you wanted. Doesn't really matter. We should get the same answer in the end. Your work might not match, but the answer will be the same. So 400 minus 205. I chose the first 2. 5/2, or 5 minus 2 on the bottom. Perform that operation, 195 divided by 3. Try to simplify that, especially when it's a word problem. We're talking about a value of something here. So if I do, I get 65. All right, so the rate of change, aka the slope, is 65. What does this rate of change represent in the context of the situation? So we're trying to figure out, if you go back up here to the problem itself, all right, what is the total cost of hiring the designer? Okay, well, if we did our work correctly, we got 65. The designer costs $65 per hour. Let's try a couple more here. Number 5, okay, no table here, right? We're gonna have to extract our values from the actual word problem itself. Post office calculates shipping based on the weight of an item in addition to a fee. The cost to ship a 2-pound item is $6.09. So that's a coordinate, 2, 6.09. While the cost to ship a 7-pound item is $8.84. Okay, so again, there's my second coordinate. 7-pound item is $8.84. Find the rate of change of the cost with respect to the weight of the item. So I'm going to do the same process, right? Okay, I have x's and y's, Label which one's my first point, which one's my second point. You can pick whatever you want. Write my formula, y2 minus y1 over x2 minus x1. I'm going to plug in the values that I know. Now it's a little messy because of decimals, but I have a calculator. It's okay. 8.84 minus 6.09. on the top of the fraction. All right, and then on the bottom of the fraction, I'm going to have my weight, okay, which is 7 minus 2. All right, so if I take my cost, all right, 8.84 minus 6.09, I'm going to get $2.75. If I divide that by 7 minus 2, which is 5. And when I actually calculate this, because I do want to calculate it, I'm going to come up with 55. Okay, so cents per pound. All right, because the dollars are on top, the pounds are on the bottom. It's still a rate. Okay, this will be a rate. If I graph this on a coordinate plane, okay, it would tell me how my line's increasing. And now for the last problem here, we're just taking a look at two different people, Jude and Yin. Okay, they both found the slope of the same line. Stands reason to believe at the end, the slope should be the same. Let's do it in pieces. All right, use Jude's points to find the slope. For Jude, I got down 2 over 3. Down 2, right 3. That's negative 2/3. For Yin, when I counted those points, it was down 6 and right 9. But again, when I type in negative 6 and 9, I get negative 2/3 when I reduce my fraction. Are the two triangles related to each other? Yeah, they have the same ratio. They would be similar triangles. What can we assume about the slope between any 2 points on the same line? It's always going to be equal. So it doesn't matter how close together those points are or how far apart those points are. All right, when you find your slope, you're always going to get the same number. All right, make sure you have your notes copied.